Hello, everybody. Let's get started here. Uh, so my name is Dilip Lucas. I work in the Azure Networking Program Management team, owning the DNS services. And today, we're going to talk about Azure Traffic Manager in general, give an overview, talk about what we have shipped recently, and also in particular want to dive deep into one particular scenario. So which is like how you can use Traffic Manager to route traffic to endpoints that are hosted in multi-tenant environments. This is a new capability that we are opening up for our customers, top ask from customers. And we'll do it by having a hands-on demo as well. So hopefully the network will work and I'll have good connectivity. So, and definitely I'm going to leave some time towards the end for questions. I'll be here. We got folks from our team as well also to ask any questions. By the way, can you guys all hear me clearly? OK. All right, so what is Traffic Manager? Traffic Manager is a DNS service that does global load balancing for customers. So essentially what it does is that it operates a fleet of highly available DNS servers around the world. And when we get a DNS query, we will determine based on the routing settings that you have specified for that to say whether we need to send the requester to this endpoint or that endpoint. And we provide you with multiple options on how you want to control your traffic. You essentially can shape your traffic so that, for example, you can say, send everything to one endpoint till it gets unhealthy, then send it to the next one. Or you can say, send, I have 3 endpoints, send 60% to one endpoint, 20% to another one, and 20% to another one. Or you can even say that when a request comes to you, you guys take a look at it and determine which endpoint is like the best for this particular caller, best in terms of low latency, and send it over. And that's one aspect of it. The other big value add from Traffic Manager is that we are always checking the status of your health point, of your endpoint, so that if it goes unhealthy, we know that we should not be sending any more of your end user traffic over to there. And we check health by essentially sending either an HTTP or an HTTPS probe or a TCP probe, actually 3 options. We will send the probe, see whether we are getting a reply back from the endpoint. If you're getting a reply back, that means it's healthy. If it's not getting it, we'll attempt a few more times. How many times it is, it's specified by the customer. And if you don't hear back from the endpoint or hear back an error message, we'll say that that endpoint is down. Let's not send any more traffic to there. So what this essentially gives you is that, this gives you like fully automated failover for your application. This is all about high availability, where if something goes down, we'll detect it. You don't have to do a thing. We'll move it over to the next best one. And since this is all happening in the DNS layer, we are not involved in the data path, the actual data transaction between the caller and your endpoint. So that's one uniqueness with the DNS-based routing. And one of the key tenets, I want to call this out specifically here, is that when we design and operate the service, the #1 goal for us, like the engineering team, the product team, is extremely high availability. And that's because we know this is a DNS-based DNS service, and if it goes down, your business is down. So we know the importance. So we always prioritize on like fundamental robustness over having the latest feature out there. That said, we are always listening to customers to understand what do you guys need, and we always try to put that into the feature set. Having said that, it's like another quick overview slide. So basically, we talked about different routing methods that we support. You can, for example, use geographic routing method, which says that all my users from a particular geography should only be sent into the Azure region that's applicable to them. Like a good example is you can say that all users from Spain should go only to our EU data center. So we will enforce that. We will look at their IP address, and we will say that, OK, this person is connecting from Spain, for example, and send them to that data center. Subnet is like a new feature we just recently launched. This is where you can say that you can specify a set of IP address ranges and say that if a request is coming from there, make sure you send them to this particular endpoint. This is, for example, you can say that if there's a particular ISP, you want to give a different experience or even block them. You can say, give the IP address range of the ISP and say that all traffic from there should be going to a particular endpoint. Failover is like more of our fundamental one where you specify that send all traffic to one endpoint. If it fails, send it to the next one. Latency is, I would say, like one of the more popular ones. This is the one where when a request comes in, we will know where it's coming from. Then we know we have internal latency measurements that measure the latency from different end user subnets in the world to Azure region. So we know that when this request is coming from, which is the best Azure region to send them to. So you don't have to do a thing. It just works in the back end. Last one is weighted round robin, where so I mentioned before, you can specify a ratio, send 40% here, 60% here. Another value out of Traffic Manager is that we give you actionable insights on your end users. So when people are connecting from different parts of the world, we keep track of it, and we'll present you with like a visual or like a downloadable metrics on like where they are from, what regions are users connecting from, what is the volume of users connecting from different regions, and what is like the latency experience they're experiencing. So you can see it in a visual map, kind of like shown here, where you can see the connections are kind of green, or like maybe some are red, etc. So you get like an understanding of saying, oh, I got a lot of users connecting from Australia, and they're all shown as red. So maybe it's time for me to put one more endpoint in Azure Sydney. Things like that. And we also provide the logs and metrics around like the UA usage. We recently announced a few features a couple days ago. One of the things is that you can add your endpoints by specifying the IP address. Previously, you had to give the actual DNS name of the endpoint when you're adding it. Now you can specify the IPv6 or IPv4 address. This is a new way in which previously we were returning only one endpoint. Now you can say, send me, return to my caller 3 healthy endpoints, so that if one of them doesn't work, actually, they don't have to redial into the Traffic Manager. They can just retry it in the client. I'll come back to the middle one, the last one. And the next one is the HTTP custom response code. So right now, when we do a health check using HTTP or HTTPS probing, we only look for 200 OK as the successful response. If you send 300 or something, we'll say you're unhealthy. But some customers have said that they want to have more of a customization there. So maybe they're sending 201, which should be a success code. Here, now you can specify what you want to be the success code. We already talked about subnet routing when we talked about it, where you can route based on the IP address. Now the last one is, this is kind of like the focus of this presentation. That's why I kept it for last. This is the ability to add custom headers to HTTP probes. Remember I said, we check the health of your endpoint by sending an HTTP request or HTTPS request. And we slap in standard headers in there so that you can identify it's coming from Traffic Manager and all. But there are some endpoints that live in multi-tenant environments where you need to add like additional headers. For example, a host header, so that it can be routed correctly with there. We'll actually work through a specific example of to show that. So that's a new feature, and we are going to dive a bit deeper into that. Sorry. OK, so let's talk about like what I'll be showing you here. So this is a it doesn't work. Anyway, so this is a let's say imagine like this is the US East region of Azure, and this you're running a virtual machine in here. That's the IP address of the virtual machine. You could have a DNS name, but for now, let's just say it's an IP address. Inside there, you're running 2 websites. Okay, you can use whatever you want to do, but for this demo, I just wrote like a very, very lightweight one using Node.js. But it can be anything there. So when like an HTTP request is coming in to get, let's say a client is dialing into this using this IP address, they will be coming in here. But at this point, you don't really know which website it should be handing it back, right? So you need to have, typically the way it's handled by platform developers is that there will be some entity over here which will look at the host header, which will say that which website is the one that you actually want, because the connection actually happens at the IP address level. And let's actually try to build that with an example over here. So let me switch it into. All right. So I've already fired up these VMs, the same IP address that I just showed you. and I'm already logged in here. So this is the VM that I have created. And I created a very lightweight program called hello.js. And let's look at the logs. But even before that, let's do something even more basic. Let's try to access this website using the IP address, right? I'm just trying to type it in here into my Edge browser. And it's really timing out. Nothing is happening. Let's take a closer look and see what's happening in here. So curl -v. So you can see that it's connected to that IP address. So it's connected to the VM. And it's sent like an HTTP request. And there's no, at the host, it's sending the IP address in there. Which means that if you go back into here, the request is reaching here, but the host header is saying the IP address. It doesn't specify the name. So nothing is happening there. Now let's switch back and see what will happen if we send it correctly. So now, instead of that, I am going to add a header called atmsite1.com. All right? Oh. That should work. Oh, sorry. I wrote the host header wrong. It should be a key value pair called host, colon. There you go. So now it's sending in this header, and it's actually getting like a website back saying that, hey, I'm ATM Site 1. I'm running in Azure East region. Right? So this is like the standard way. Whenever you are typing in like a URL like ATM Site 1 in your browser, it is actually sending it by default into the all the way into the host as a host header. Now, having said that, let's go back and see. So we just demoed, like, when we add the host header, it actually gets redirected correctly into that. This is all good. Now you may be asking, what's this to do with Traffic Manager, right? So this is a scenario. So Traffic Manager is a DNS service that does all these DNS things. But on the other face of Traffic Manager is that it's an HTTP client that makes a lot of these requests into different sites to get help. So what I did here is that, whenever you're developing something with a high availability, you want to put it in a different region. So we had this before. I added the same thing in a new region, right? And now I want to use Traffic Manager to make sure that customers get routed correctly. So if this thing one goes down, it gets corrected routed into there. But to do that, Traffic Manager needs to go and probe the correct website. So this Traffic Manager was created for this particular website, atmsite1.com. So it needs to make sure that the probes are going in correctly into here and not like really getting stuck like the way it is right now. So if you do a health check without the correct host header, this is what's going to happen. So let's get back and see how this works out. So in here is the Traffic Manager profile that I talked earlier about. And I have added these two as the same IP addresses that you are seeing you already saw in the screen. And let's see. So let's actually knock these down by, see here I already have the host header. Let's say that I am saving this. We have the ability to do custom host headers, but assume that we are not doing it. So when that happens, soon enough you'll start seeing that. So these are like, I'm just like showing the logs from the HTTP server. So very soon you'll start seeing that Traffic Manager will stop sending. Yep. So if you see this right now here, before it was sending it with the correct host name in there, but now we took away the custom host name, so it started sending in just the best thing it knows, which is its own host name. So when that happens, if you actually go and try this as the host header, you can see that it will fail. Let's go back to our demo here, and let's say instead of this, if you put this as the host header, see, it's not going to happen. It's just going to fail. And this will soon be reflected in the status of our endpoints. Let's go and see how they're looking. See, now they're both degraded, which means that Traffic Manager really cannot get a response from them, so it's considering both of them to be unhealthy. And that is bad because when that happens, we won't stop working. We'll just randomly select an endpoint and send it back to you. So the way to fix it is just like I had before. You go there and put the host header setting that you want to use, host atmsite1.com, right? And you know what? Just for fun, let's also try to add one more host header in there. So you can add multiple here. I don't know, foobar or Ignite 2018, something like that. If my demo works, it should all show up in the other logs that I'm showing to you later. So let's see. When I do this configuration here, it is applicable to both endpoints. But if you actually want to override the host header for or any header for only one endpoint, you can go into that particular endpoint and change it over here. It will be applicable only there. But for this one, it's applicable everywhere. So let's go back and see how this thing is doing. It still hasn't. By the way, you guys are seeing an ATM site too because I created a different Traffic Manager profile for that one too, but ignore that for now. See, it's still getting ATM site 1 Traffic Manager. And by the way, our probing works from different websites across different regions across the world. So you'll see more than one hitting your endpoint. And we have actually published the IP addresses of all the endpoints so that you know if something is. So that if you want to close up your endpoint for everything but this Traffic Manager probes, you're able to whitelist those. And there you go. If you guys just saw this thing, this latest one came in. And it has the host header that we specified, host atmsite1.com. And it also has other random headers we just put in there for the kicks. So now, Traffic Manager is properly getting routed into a real website in there. And it should start working soon. So let's go back and see the status of the Traffic Manager profile. Traffic Manager endpoints. Oh, there you go. They are already online. So, which means now it's ready to route. And the way I configured it is the routing method is priority. And I've said that the priority of the East US VM. So now I have 2 VMs, right? East US VM is priority 1, which means all traffic will go there until it fails over. If it's unhealthy, then it'll go somewhere else. So let's go back and see what we did in terms of a diagram. So this was a scenario. Now we started putting the host header, so it's not now getting correctly all the way till here, and it's actually getting the responses back. So now this is essentially where Traffic Manager is now working with multi-site endpoints. And one of the other services that Azure has is Azure DNS. This is a DNS service for static DNS hosting, extremely highly available. In fact, our published SLA is 100%. This is the only Azure service, I believe, that has 100% SLA. And it has very tight coupling with Traffic Manager. So if you have a site, so for this demo, I created an actual DNS entry for this site to be hosted in Azure DNS. And I created an alias record type to point to the Traffic Manager profile. With an alias record type, there's a lot more integration than just adding a CNAME entry in there. By a CNAME entry, will just send you a redirect. The client will have to do the next DNS lookup. But with an alias, we'll do the CNAME chasing on your behalf. If something happens to this Traffic Manager profile, we'll know it before the query lands, so we'll handle it. And more importantly, what this integration opens up is the ability for customers to do traffic management at zone apex. Zone apex means atmsite.com, not www, the root of the zone. Previously, it was not possible because of a limitation with CNAMEs. Now, with alias record type, you are able to do that. So with this picture in mind, so I have an ATM site here, atmsite.com hosted. Things should all work. Let's just see if it's all going to work. So as you can see, the name of this traffic manager profile is called ATM Site 1. I'm going to go back into my dashboard real quick. And this is the DNS, Azure DNS blade. So here, I'm hosting ATM Site 1. And for the root, I am aliasing it into a traffic manager profile. This alias feature is something that we just shipped like a few days ago here at Ignite. So you can alias from a DNS zone to traffic manager profile or a public IP address. And more integrations are coming soon. So it's very exciting top asks from customers. So having said this, let's try to see how this whole thing is wired up. So let's see how this thing is. So ATM Site 1 is hosted by Azure DNS. And instead of a CNAME record, which will take you multiple times to like the next provider, etc., when the request lands on the Microsoft Edge, we'll do all the chasing back and give you back the IP address. So Traffic Manager is behind it. So it doesn't show in like a standard dig query. But this endpoint that we are getting back is the same one that we have been operating on. Okay? So now the demo essentially becomes, let's try to navigate to that website. atmsite1.com. There you go. So this is Hello Ignite. I'm running in Azure East region, and my name is atmsite1.com. So as per the traffic manager settings that we have, all traffic should be sent to the East US region. Now, this is great. Now we know that traffic manager works for multi-site endpoints, but what's a traffic manager demo without failover? So let's try to simulate that. What I'm going to do is that I'm going to go back into the, so this is my endpoint, and I'm going to stop. This is the US endpoint. So I just stopped that web server from running, and it should soon be evident in the traffic manager profile. It'll pick it up as fast as you want it to be. Sometimes you can specify that, like, hey, try a couple times before declaring it to be unhealthy. Or you can be like within 10 minutes, just, within 10 seconds, just fade it over. So let's go back to this one right here. So it just detected that US East is degraded. When this is degraded, that means all traffic should go here. So the finale of my demo should be that when we refresh this website, it should say that it's running in East Japan and not in East US. Let's see if it works. So right here, from East US, it should go into Japan. Oh my God. Sorry, the traffic manager also has a DNS TTL of, like, I believe, 10 seconds. So TTL is something you configure here, which means the response that it gave back earlier will be the response that it'll be using for the next 10 seconds. So let's just wait for a couple more seconds before we attempt it again. All right. Let's try it without the cache. Ah, there you go. So there were some cache effects in between that almost derailed the demo, but now you can see that it's saying, I'm running in Azure East Japan region, and my name is ATM Site 1. So this shows that Traffic Manager just failed over when I took it out. Are we in time? Over? OK. So he's ready to throw me out of here. But I'll be here to answer any Traffic Manager, DNS, or in Azure Networking in general questions you have. Got a few stickers for you for Traffic Manager and DNS. Feel free to pick a few. And thank you so much for your time here.